Make the notion of rounding a little more precise by using the floor function. Now this particular example is just kind of arbitrarily chosen, but right here, this is an example of rounding up. If somebody told you to round up 2.8, they would tell you 3 quickly, right? Okay, and also 3.49 would be rounded down. Notice that both of these numbers are contained in this interval 2.5 to 3.5. It's the closed open interval. We want to try to make this a little more precise. Let me write this. We rounded down here, right? Rounded down right there. Okay. So we want to make this a little more precise using something called the floor function. Sometimes some people call it the greatest integer function. Now let's just do a concrete example right here. Let's say we have the floor of, let's say, 7.6. The floor of 7.6. Again, a lot of people call this the greatest integer function. 7 is the greatest integer that is less than 7.6. Okay. Now notice right here we would have 7 less than or equal to 7.6, strictly less than 8. Okay. So this is a definition of what we mean by the floor function. There's a corresponding definition for the ceiling function. Now notice how this particular interval was split down the middle, so to speak, and that motivates this definition of rounding. The floor, you round a number x based on the floor of x plus 1/2. Okay, and you can see that this is just a carbon copy of this, except we have x plus 1/2. It's exactly the same as what's above, and this becomes our definition of rounding. You know, so for example, well, actually, we'll just write it. Here's a little more clear right here, folks. So let's go ahead and let's say we want to round 6.3. Okay, we want to round this. Okay, well, that would be equivalent to considering 6.3 plus 1/2, which is 6.8. Right? But notice you get the expected outcome here. You get 6. Okay? So this is a fairly simple but natural extension of the floor function. Now, let's just maybe one more example to use both halves of it. Let's do maybe, I don't know, 7.9. So we want to round this, and we get, if you add 0.5 to 7.9, you get 8.4. Okay, and that's exactly equal to 8, right? Which is anticipated. If you round up 7.9, you get 8 just without doing any prodigal math. But this is the floor function way, or the greatest integer function way of making this happen. So again, this would be your definition. These two numbers fell within the specified ranges right here. I didn't write them down, but it's pretty clear, you know, what's going on right here. That 6.8 is between these ranges for the choices of k that happened here, where k equals 6 in this case, and k equals 8 in this case. But anyway, check out this definition. Again, it's not too much to it, but it is kind of a cool way of making rounding formal. So anyway, that's it. Thank you for viewing.